area of cross section of the tap. So I think you're going to see this, there's a situation at an instant of time. What is the equation you're going to write it? This will be very important. It will help us in nuclear physics. Huh? This idea will help us a lot in nuclear physics. No. Shall we proceed here? No. So the moment you switch on tap, so the level of water starts increasing. As the level of water starts increasing, the flow rate here will increase. The flow rate will increase. So what actually, so shall we say like the rate at which the level of liquid rises, or the flow rate, the rate at which water supplied by the tap. I'll write the rate equation. Try to see it. So we'll write the equation here. The rate of supply of water is equal to rate at which water increases in tank or vessel, in vessel, minus rate at which water is discharged in vessel. Am I right? So the rate of supply of water. Okay, plus this should be the rate of supply of the water by the tank. Let it be Q naught. We assumed it. The rate at which water increases in the vessel. Shall we write A dH by dt? Why positive sign? Anybody, why positive sign? If the level of liquid increases, it should be positive. Plus rate at which water is discharged. A into V. Discharged by the hole. Better right. This is a rate equation. So what we wanted, okay, dH, so this will be A dH by dt. I think I'll write this step here. Below that we'll write it. Yeah. No. So what is A dH by dt? You can write it as Q naught minus AV. So further next step, dH by dt Q naught A. What is V? Root of 2GH. Q naught minus dt by A. This what happened, I should integrate to get the initial, it was empty. So at any instant of time, what is the height of the liquid in the vessel? Will agree this. So it's a mathematically may not useful for us. Now, after what time the level of liquid in the vessel will be maximum? Anybody? It will not, it may overflow. When it will overflow, when Q naught is very much greater than A root 2GH. In that case, what will happen? Some liquid, what happen, will be discharged by the hole and the level of liquid has risen and they'll be overflowing. When that will happen? When Q naught is very much greater than root of 2GH. In some situations, what actually happens is like as the liquid falls here, the tap, if this hole is very big, then what all liquid comes out and will get discharged. No, that happens when this is very much greater. No question of liquid rising up. The liquid comes here, will fall. That is of no use. Then the flow rate and the hole dimensions are such that the level of liquid will become constant and there is a maximum. How to calculate that maximum? How to get that maximum? So what is the maximum level of liquid in the tank? Let me put everything in this order somewhere here. Let it be. Okay, fine. Now the level of liquid in the tank will be maximum. How to calculate the H max? So when the level of liquid becomes maximum, it will remain constant or constant. When that will happen? When the the rate at which water supplied by the tap should be equal to the flow rate of the hole, the flow rate at the hole. So this will happen when Q naught is equal to A into V, or Q naught equal to A into root of 2G H max. So what is the maximum level of the liquid in the container when the flow rate of the tap becomes equal to the flow rate of the hole? What is the flow rate of the hole? AV. Then what is the velocity of Flex? It depends upon the height level of liquid. So it has achieved maximum. So this is the maximum level of the liquid in the container. If this condition is satisfied at one instant, what happens? Initially, the level of liquid will keep on rise. As it keeps on increases, H will increase, V will increase. At one instant, what happens? When this flow rate at the hole becomes equal to flow rate of the tap, what amount of liquid per second entering, that much of liquid per second will leave. Then what happens? Amount of liquid in the tank remains constant. So that is what we say maximum. How to calculate maximum? There's a formula. If you are good in integration, if you want, you can solve for T. I just left it. May not be useful for us. That's why I just left it here. There's another condition. So I can put a hole in a vessel. What is the time